So example 1 continues on the back. So B part says graph Sarah's distance as it relates to time. So you need 2 points to plot to graph a line. Let's label these axes. This is time in minutes. This is distance in kilometers. So you should always tell me the unit of measurement, because time can be seconds, minutes, hours, days, weeks, months, years, okay? And the same thing with distance. We can have meters, kilometers, etc. Okay? So we started at 0 and 0. That's 1 point. And the other point was 20 minutes, and she ran 5 kilometers. So with those 2 points, with a ruler and only a ruler, and we always extend it to the end of the grid, we graph that line. Okay, letter C says, explain the meaning of the rate of change and how it relates to the graph. So the rate of change, 2 points here. Rate of change is Sarah's average running speed, which is also the slope of the graph. So again, speed and slope is the same thing. Okay? Here's a nice example, example 2, which I like. So it says the graph shows the volume of gasoline remaining in a car's tank. So understand the graph first. We've got distance down here. We've got volume of gasoline in the tank over here. Okay? Calculate the slope of the graph. Well, you've got 2 points here. We're going to use those 2 points in our slope formula. And here's where I'm going to give you the new formula that we use from now on. Okay? So, your slope formula, small m. Instead of writing rise or the change in rise, this is our rise, which are our y coordinates. So what we write is we write y2, which is one of the y coordinates, subtract y1. Now these are not exponents, okay? These are y2, which is the second coordinate, minus the first coordinate. Over, instead of writing the change in the run, we're going to go x2 subtract x1. Okay? So we've actually got 2 coordinates. Here's one coordinate. Spread this out a little bit. Here's a second coordinate. Okay? Now what I tell my students is identify these 4 numbers to match these guys. So x is always first, y is always second. X is always first, y is always second. And I like to call this my first group because it's my first coordinate. 1, 1. I like to call this my second coordinate. 2, 2. Okay? Now it doesn't really matter which one your first coordinate is or which one your second coordinate is, but what you can't do is you can't go x1 and call that y2. Okay? So the 1's stay together, the 2's stay together. X always goes first, y always goes second. And now all you got to do is substitute these 4 numbers in our slope formula. So y2, 5. Drop the subtraction. y1, 65. Over x2, 500. Drop the subtraction. x1, 0. And now we're going to solve our numerator, negative 60. Solve our denominator, 500. Put it as a decimal, negative 0.12. Now, negative 0.12 what? Where are your units? What are your units? Your units are negative 0.12 liters, capital L is liters, per kilometer. Okay? Got it so far? Now, interpret the slope as a rate of change. So explain what this really means. Okay? So interpret it as a rate of change. I'm going to add letter C over here, which is very important, which I'll show you after. I'm just giving you this for space, okay? So interpret this. So that's great that you came up with a slope of negative 0.12, but what does that mean? What did you actually do? It means that the car uses or burns how many liters? 0.12 capital L liters of gas per kilometer. So let me explain this. The word burns takes care of the negative, okay, because you're losing gas, okay? If this would be plus, you'd be gaining gas, which kind of doesn't make sense, okay? So the more we drive, the more we burn gas. So the negative takes, the word burns or uses takes care of the negative. 0.12 liters of gas. Okay? Now the important part we're doing in all this and where this is all going is we want you to come up with an equation for this line. Okay? We want you to come up with an equation for this line. Well, think about it. You got your slope, which is that, and you've got your vertical intercept, where the line crosses the y-axis, which is important, okay, which I'll talk to you about more later on in a bit, okay, which is 65. So it hits the line at 65. With those two things, we can make an equation or a formula. Here's my formula. So let's do the question first. So the question might be, what is the equation? Here's my equation. Capital V, which stands for volume of gasoline, is equal to, slope comes first, negative 0.12, with the D variable, and then your y-intercept, or your vertical intercept, which was plus 65. Okay, why do we have a formula? Because I can put any number, my bad guys, sorry. I can put any number in for D, okay? And I'll figure out how much volume of gas I'm going to be using, okay? So if you're going 500 kilometers or you're going 520 kilometers, I can put 520 in here in brackets and it'll tell me how much volume of gasoline I'm using, okay? And you can also do the opposite. You can put how much volume you got. So maybe you got 95 liters of gas. How far can I go with that amount? Okay, so you're going to put a number in for there, and then you're going to solve for D. Okay, so this is very important in today's lesson, that we're able to fish out an equation which is like a formula given a line. Okay? And the only thing that you need, the only two things that you need is your slope right there and your vertical intercept right there. Okay?